Hi friends, welcome back. Today we are going to solve one very important coding interview question, minimum spanning tree. So this asked by Amazon, Microsoft, Flipkart and many other big companies in their interviews. So make sure you watch this video until the end so you completely understand the logic how we can implement this coding problem using Java. Before we start looking into the problem details along with some examples, I would like to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find out more than 500 different varieties of coding problems solved and explained using whiteboarding session examples and Java code. Many of those problems are previously asked coding interview questions asked by big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, LinkedIn, Netflix, and many others. Among those solved coding problems, you will see all important coding questions varieties are covered in them. That includes problems related to binary search trees, graphs, matrices, linked list, strings, optimization problems, dynamic programming questions, problems related to breadth first search, depth first search. A lot of data structure related coding questions are also covered on this channel, including stacks, queues, priority queues, hash map, hash set, tree set, hash table, uh, linked hash map, linked hash set, and many other important coding problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn more concepts, programming, data structures, algorithms, problem solving, logic building, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, whenever we come across any important coding problems such as this one, we often create videos on this channel to discuss more about the problem, logic and approaches to solve different varieties of problems and implement those problems using Java. So others can also learn how to solve different varieties of problems. So make sure you click on the bell notification icon so you won't miss any important postings from this channel. So let us start with this important coding problem, minimum spanning tree. Given a weighted, undirected, and connected graph of v vertices and e edges, find the sum of weights of the edges of the minimum spanning tree. So we have to find out the sum of weights of the edges of a minimum spanning tree, right? They have given one example, and I also created another bigger example. We'll take both these examples so you will completely understand the problem. So this is a totally connected graph that is given to us, right? So this, for example, input graph is given and every edge has some weight, right? And this one is a undirected graph, right? Undirected, so there is no direction to the edges, right? So but every edge has some weight associated with it, right? Like for example, edge from 0 to 1 has a weight 5, right? From 0 to 2 has a weight 1, and 1 to 2 has a weight 3. So now what a spanning tree means is that we want to actually start at some vertex in this graph. For example, we start at 0, then we can go to 2, and then from here we can go to 3, right? So it is a spanning tree because we can actually visit all the vertices from this tree, from this node, correct? So 0 we can visit, 2 we can visit, 1 we can visit, right? So all the vertices we have visited. But minimum spanning tree means that the total of the weights, here the weight is 1, here the weight is 3, the total is going to be 4, and that is the minimum weight basically, right? That is required to connect all the vertices of this graph, right? If we take 5, let's say if we go from 0 to 1 and 1 to 2, right, then how much weight it will be? 5 plus 3, which is 8. So this is not a minimum spanning tree, right? This is a minimum spanning tree because its weight is the least, right? Smallest weight, right? 3 plus 1 is 4, and all the nodes are also connected, correct? So we have to find out a minimum spanning tree for the given graph, right? And what we are going to return as the output, we want to return the weight of that minimum spanning tree. So that is what the problem is asking us to do. So let's take a look at some other example here. So this is another graph. So we want to find out a minimum spanning tree of this graph, right? So let's take this example so you will understand more better right here. So now if we start from index 0, right, then we can choose this edge. Let's say we have chosen 4, these edges we have chosen, right? 4, 8, 6 and 12. These edges we have chosen basically, so that we actually get the all the vertices will get connected to each other, correct? We have not chosen this edge, right? We have not chosen this edge. Why? Because we want to find out minimum spanning tree. If we choose this edge, then it will not give us minimum weight, correct? That's why we have not chosen this edge, right? So if we have not chosen this edge, then how much weight we will have to actually we will get 8 plus 4 is 12, 12 plus 12 is 24 plus 6, which is equal to 30. So 30 is the answer for this graph, right? This is the minimum weight that we will get actually from this graph, and this is the minimum spanning tree. So just to make sure that you completely understand it, what we will do is what essentially we have done is we have removed this edge basically, correct? So we have removed this edge from this graph. So now this became a tree, correct? And this is a minimum spanning tree, and its weight, total weight, if you calculate it, is 30. So that 30 is what we have to return as the answer to the question. So this is what the problem is asking us to do, right? So it is a basically graph or tree problem, correct? So now I'll just put this edge back. Why we have just decided to remove this edge? We can remove these other edges also, right? But if we remove, let's say, this edge, let's say if we remove this edge, then how much is the total we are going to get? 12 plus 6 is 18 plus 4 is 22 plus 10 is 32, right? So that is not a minimum spanning tree, right? We have seen a sum which is 30, which is smaller than this, right? So that's why we have not we have removed this edge. If we remove this edge instead, still the graph is remain connected, right? But the weight is not minimum, right? How much weight we will get here? 12 plus 6 is 18 plus 8 is 26 plus 10 is 36. So we already have seen 30 weight, which is the minimum, right? So this is not actually the minimum weight, right? So this is why this is not the minimum spanning tree. If we remove this edge, right, if we remove this edge which is contributing 10, then this is the actually minimum spanning tree. So with these examples, now you have understood what the minimum spanning tree and what actually the problem is, right? So now let's discuss how we can solve this problem. um, so let me choose a pen quickly. So now first thing is these edges are given to us along with its weights, right? For example, 0 to 1 is the edge and 8 is the weight, right? So all these edges and all these weights are given to us in the input. So what we will do is first we will create a adjacency linked list, right? This is a adjacency linked list or graph, but this is actually also accounting the weight. For example, if you look at this one, right, this is the array list of array list, correct? I'll repeat it again. It is array list of array list, right? Which is also called as adjacency linked list, right? Or another terms is graph. Adjacency linked list is the way how we represent graph, right? One way. So now, for example, if you look at here, how it will be internally represented, right? So this is for the vertex 0, right? This one is for vertex 0. So if you take a look at this vertex 0, then there is edge 2, 2, right? Its weight is 4. So this is what we are capturing here, right? 0 to 2 weight is 4, 0 to 3 weight is 6, right? 0 to 3 weight is 6, 0 to 1 weight is 8, 0 to 1 weight is 8. So this is how we will first capture for all the vertices, right? So this is 0. If you look at this one, this is 1, right? So 1 to 0 weight is 8, right? 1 to 0 weight is 8. 1 to 2 weight is 10, 1 to 2 weight is 10, like this. For all the vertices we will get this. So first we will create this one, right, which is a adjacency linked list, but it will account for weights also, right? So once we have done that, then what we will do is we will start doing like basically now we know this graph, right? So we will start iterating from node 0, right? So we will go to node 0 and we will actually but how will we make sure that we will get the minimum weight, right? To get the minimum weight, what we will do is we will use a very important data structure, right, which is called as priority queue, correct? Priority queue is also called as min heap, right? So priority queue is a class in Java, so that's what we will use. And in this case we will be using min heap implementation of priority queue, because we want to keep track of minimum edges, right? So we will keep starting at 0. We will put this edges into the priority queue. So in the beginning there is a weight is 0, right? So weight is 0 in the beginning, correct? Now we'll start with 0. We will add this edges, right, into the priority queue. So we, whenever we want to get the edge, we will always get the minimum edge. So this is the minimum edge, right? So 0 to 2. So we will also keep track of what vertices we have visited, right? So when we visit 0 to 2, these vertices we have already visited. How much weight we have gotten here? 4, right? So we'll add 4. So weight becomes 4. So next time when we ask for another edge to the priority queue, it will give us another smallest edge. So this one we already used, right? So next smallest edge is this one, 6. So we will add 3 into our visited nodes, because we are going to visit 3, and we are going to add this 6 into our weight. So once we add 4 plus 6, it becomes 10, correct? 10. So after that, when we again ask priority queue, next time give us the smallest edge, it will give us this edge now, right? This is the smallest edge. So we will add 1 to our visited nodes, correct? And then 8 we have to add into 10, so we have added 8, so it becomes 10 plus 8 is 18, correct? Now this is important, right? When we again ask next time, give us the next smallest weight, right? Next smallest weight edge, so it will give us this edge, correct? Now when we are asking it, we are actually here, right? And we have visited 1 as well as 2, correct? We have visited 1 as well as 2 in this. We have already captured this information, right, in the implementation. So now when we get this age 10, then we will decide that we already have visited 1 and 2. So we are going to skip that age, correct? Because the main goal of the spanning tree is that you should have access to all the nodes, correct? So now we already have access to node 1 as well as node 2, correct? Because we have access through this edge, which is having weight 4, and through this edge which is having weight 8, correct? So that's why when we get this edge next time from the priority queue, we are going to ignore it, right? Because we already have found out a minimum path to visit 1 as well as 2, correct? So we'll ignore this. Again we will ask to give us the next edge, so it will give us this edge. We will take this edge because we have not visited 4, so we will visit that edge. We'll add 4 into our visited array, and then we will add 12 into our weight, so that weight will become 30, correct? So now this is what we will return as the answer at the end, right? So this is how we will find out minimum spanning tree of the given graph. So I hope it is clear to you now with this example and detailed explanation how we are actually going to implement the minimum spanning tree, and how we are going to find out the minimum weight of that minimum spanning tree. So so let's go to the code, then it will be more clear to you. This is one of the very important coding question asked by many big companies in their interviews. So that's why I'm creating this video, to explain you how we can solve this kind of problem. So let's go to the code, it will be more clear. So this is our um, uh, minimum spanning tree class, right? So first thing is edges are given to us, right? This is the input. So for example 0 to 2 is the edge, its weight is 4. So if you look at this one, so 0 to 2 is the edge and its weight is 4, correct? So if you go through all these things, this is how the graph will look like. 0 to 3 weight is 6, 0 to 3 weight is 6, like this. So if we connect all those edges, this is how the graph will look like, correct? So this is how the graph will look like. So now this is given to us, and number of vertices are 5, number of edges are 5. Then this adjacency list is what we are defining here, which is array list of array list of array list, basically, correct? Because we are going to capture um, all the basically adjacency link list that will also capture the weights, right? That's why it will look like this. So you will come to know once we go through this code more. So so first thing is we'll go to through all the vertices, and we will add into the adjacency list. We will have to first create a array list of array list empty, right, for all the vertices, right. Then we will start iterating through this while loop. While I plus 1 is less than equal to e, it means that we are basically what we are doing in this while loop is we are going through all these edges, right. So we are going through all these edges. We will read all the values which is uh, from edge to edge, and then weight, right, u, v and w. So the edge is from vertex u and edge is going towards vertex v, and it has a weight w, correct. So we'll read that information from these edges. After that, what we are going to do is we are going to create two different array list here, t1 and t2. So what we will add into that array list, we will add v and w into the first array list, and we will add u and w into the second array list, right. Because what I explained you in the example also is we are going to capture the like the um, neighbors along with the weights, right. Neighbor along with the, so this is the neighbor and this is the weight, this is the neighbor and this is the neighbor and this is the weight, correct. Because this is a undirected graph, that's why we have to do both directions, right. That's what we are doing. So we will just adjacency list dot get u will add t1 and get v we will add t2, correct. So this is what we will do basically, right, I plus plus. So we have actually now, once we go through this while loop, then we have our graph ready. Graph is ready as a adjacency list, right. So now our adjacency list is ready. So I'm going to show you how it looks like internally. So that's why I'm printing it here, but I already showed you here, right. So the adjacency linked list will look like this, correct, internally. So this is, for example, this is array list of array list for node 0, correct. So these are the neighbors, right. 0 neighbor is 2, 0 neighbor is 3, 0 neighbor is 1, right, and the weight is 4, 6 and 8. So this is how it will internally look like. So let me just save this. So now we are going to call the spanning tree method on this, right. We'll pass this adjacency list, we'll pass number of vertices, correct, and then we will go through this method now, this spanning tree, right. So initially weight is 0. We are going to define the priority queue which is actually holding list of integer, right. Because why list of integer? Because this adjacency list is actually having list of integers here, right. And how are we going to compare? Because whenever we define a priority queue, we have to also specify how we want to how we want the priority queue to sort the elements, correct. So we will use the weights to sort, right. So minimum will be weight will be on the front. So whenever we ask for edge, it will always give us the minimum weight edge, right. So this is what we are doing here, right. A dot get 1 minus b dot get 1. So 1 is edge, like, sorry, 1 is weight, right. So as you can see here, right, as you can see here, this is weight that we add here basically, right. I'll just show you here. So this is 0th element in the list, right. Let me just show you. So this is 0th element and this is the one element, right, because array list starts as index 0. So one is actually, one index is holding weights, right, 4, 6, 8. That's why we are going to compare based on the weights, right. So this is what we will do in the priority queue. So to start our BFS like approach, right, we are actually going to need some starting point. So the starting point will be 0 comma 0, right. Initially weight is 0 and we are starting from node 0, correct. So that's why we will create a array list of 0 comma 0. We'll add it to our priority queue here, and then we will start our BFS like approach here, right. So we'll also keep track of what nodes we have visited by using visited nodes boolean array. So this is where our main code goes now, right, while pq is not empty, right. So there is something to process inside the priority queue. Then we will remove that node from the priority queue, right. So this is the node. It is basically list of integer, right. So what it will give us is this one basically 2 comma 4. This is what we will get, right. 2 comma 4 is what we will get here, which is list of integers. We are just going to print that here, and then what we will do, first thing we will check is, did we already visit this node, correct. Did we already visit this node? This is what we are checking. If we have already visited that node, we are going to skip it, correct, because it means that we already found out a minimum weight path to reach to that node. So we are going to ignore this new path. For example, here, right? So I'll just remove these colors. So for example, when we actually first gone through 4, then 6 and then 8, right? We have visited 0, 3, 1 and 2, right? Then when we get this edge, we already have visited this 1 and 2. So we are going to ignore this edge. So this is what we are doing here, right? So it's already visited. So we will not be actually, we'll be ignoring it or skipping it basically, correct? We'll skip it. Otherwise, we will add that weight of that edge into our this weight variable, right? Node dot get one. So one is the weight, correct? As I just explained you, the one index is the weight, right? This is weight. This is the index one in the list, right? So we'll add that into our weight here. We'll just print it. This is just to show you, right? And we'll remove it later, and then we'll mark that as a visited, right? Because this node we are actually visiting. The node dot get 0 is the node, right? That we are visiting it. So we'll mark it as a true. We will go through all the neighbors of that node. Here we are going through all the neighbors of that node, correct? And what we are getting here, we are getting the adjacent neighbors, right? It is list of integers, and we will prepare this temporary list by using n.get0 and n.get1, correct? We will prepare that list, and we will check if we haven't already visited this new node, right? n.get0, if we haven't already visited it, then we are going to add it into priority queue, correct? If we have not already visited it. So this process will continue processing all the edges, and at the end we are going to find out the minimum weight here, right? So why we will find out minimum weight, why it will work? Because the way we have created the priority queue, right, it always gives us the minimum edge first, right? So it will give us, so when we go in sequence, here, we will first get 4, this edge, right? 4, then 6 this edge, then 8 this edge, then 10. But 10 we will ignore because we have already visited 1 and 2, and then 12 we will get, right? So total will be 30 if you calculate. So this is how the code will work. So we went through the code statement by statement. We have seen the code in complete detail. So now we will just test out our code, make sure it works. So we are expecting 30 as the answer for this graph, right? As the minimum spanning tree. So let's execute this code snippet. So we are going to now execute this. So this is the weight that we have found out, 30, which is the correct answer. And this is just to show you how the graph internally gets created, right, as an adjacency linked list. So I already showed you this. This is the same thing that we have seen here, right? So then first thing we will start processing is at the node 0, 0. So let me just make it small so you can read this thing, right? So now we will start at this 0, 0, correct? And then we will take this one, which is the number 4 edge, right? So our weight will become 4. Then number 6 edge, so no, weight will become 10, right? 4 plus 6 is 10. Then number 8, like weight 8 we will take, which is 10 plus 8, which is 18. After that we are going to get this edge 10, right? Now this 1 and 2 we already have visited, so we are going to skip this. So I'm just writing out a statement there, so you will know. So skip processing this node, right? 110, because it's already visited, and it means that we already found out the minimum weight path to visit 1 and 2. So we are going to skip it, and we'll go to the next one, which is 12, right? So we'll add 18 plus 12, which will become 30. So this is how the code works internally. So I hope it is clear to you now how the uh, implementation is done using Java for this minimum spanning tree problem. So I'm going to add this code into my GitHub account, give you the link of my GitHub account, so you can go check out the code. You can create your own graphs here, right? And then you can see how it finds out the correct minimum weight spanning tree, right? So this is one very important coding problem previously asked by Amazon, Microsoft, Flipkart and many other big companies. If you are new to this channel and if you haven't already checked the very important playlist on this channel, I would like to mention that there is a very important playlist available on this channel. Its name is Leetcode and Leetcode Solutions. That playlist is very important because it captures like very frequently asked coding interview questions that got asked in recent interviews many times by many companies, right? And there are more than 250 different varieties of coding problems you will see in that playlist. All are very important coding interview questions. So if you go through those videos, you are going to learn a lot there, more about problem solving, logic building, data structures, algorithms, how to approach and solve difficult problems, and how to implement them using Java. You will also learn more about Java programming language, what are the important Java classes that we often need during the implementation. So check out those videos. Those are very good problems and frequently asked interview questions that will also give you really good practice for your interviews as well. And if you simply want to learn more concepts also, you will get to learn a lot there about algorithms and data structures. So check out those videos. I'll repeat you the name of that important playlist. It is Leetcode and Lintcode solutions. Apart from that, if you still want to, if you still are looking for more coding problems for your practice, then there are three other playlists available on this channel that you can use for your practice. The names are Code Forces, Code Chef, and AdCoder. So all in all, there are about 500 different varieties of coding problems available on this channel, solved and explained using whiteboarding sessions and examples for your easier understanding. All the problems come with Java solution code, where the code is available through GitHub repository. You will always find out the link to the solutions in all the videos description section, so you can check out the code. If you like this video, if you find this video helpful, and if you like the way the video is created with this whiteboarding session, examples, and Java code, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of this channel is to help people in their coding problem solving and in general in their learning process, by creating content that others can use to prepare well for their interviews, and they can also use it for their learning process. So they can learn more about problem solving, data structures, algorithms, logic building, as well as improving the logical skills that is required for different varieties of problem solving. So if you like this video, give it a like, share it as much as you can with your friends and colleagues, so they can also watch and learn from these videos. uh, if you like the videos on this channel, if the videos on this channel are helping your learning process, then don't forget to mention that by writing comments onto these videos. Your comments are very important for us. That increases our motivation to create more such good quality content. So if the videos on this channel are helping your learning process and your coding interview preparation process, then do mention by writing that in the comments on these videos. Also, if you want us to create videos about any particular topic related to computer science programming, as well as about Java programming language, then also mention that by writing into the comments. Apart from coding questions, there are also a lot of relevant Java J2E related interview videos available here that discusses, for example, frequently asked telephonic Java questions. Those videos are also available that you can use to prepare well for your interviews. There are also relevant videos available about Java design patterns, Java architecture. So check them out as well. Keep coding, keep learning, keep solving different varieties of problems, and keep your learning process going on continuously. And thanks for watching this video.